is just on parabolas, and parabolas are the U-shaped curves, and they can be going up. The ones we're going to study will be going up or down. You can definitely have parabolas that go to the side, but the ones we're going to be studying, we're only going to be studying the ones that go up, and of course the ones that could also go downward. So there's some characteristics that we're going to cover. What does it mean by the axis of symmetry pertaining to a parabola? The vertex, the y-intercept, and the x-intercepts. All right. Okay, so first thing I want you to do is look on the picture and go ahead and write this equation down. This is the equation for this particular parabola. So it says f of x equals to x squared minus 6x plus 5. So if you were to put this onto your calculator and hit graph, this is the shape you would see, which is called a parabola. All right. Now we're going to go over certain things about this parabola. We are going to be studying the parabola in standard form, but there's also a form called vertex form. So you can put the vertex form as well, which means they write the equation based on the vertex. Okay. Now this equation and this equation, they are equivalent. That means they are equal. So if I actually FOIL this out, I will end up with x squared minus 6x plus 5. Okay, so they are equal, it's just in a different form. All right, so right here, okay, this point right here, that is called your vertex. So right where that parabola dips, okay, and of course, if it's going this way, you need to probably just make a picture of one going down, then that means the vertex will be right at the top. Now that's going to be important to know, because if the vertex is at the bottom, it's going to be the lowest point on your parabola, and we're going to call that a minimum point. Okay, and it makes sense. It's the lowest point, so it has to be the minimum. Now, when it's flipped and it's going downward, then that's going to be called the maximum point. Okay, that's the maximum point. Now I'm going to show you how to get this line that's cutting the parabola in half. So see this dashed line right here? It goes straight through the vertex. Okay, that is called the axis of symmetry. So it makes it symmetric. Okay, so that means it's mirroring the same thing on both sides. Okay, so we could have one going here as well. Okay, that line that cuts that parabola in half is called your axis of symmetry. Okay, so that would be that red dashed line. And notice they've already given you the equation to that, x equals to 3. And it will start with x because it is a vertical line, so it's not going to say y equals. Remember, all vertical lines start with x and just a constant. Okay, no other y's or anything like that. So we're going to find out how to get this equation. So that's what we're going to be studying today. How do I know what this equation is for the axis of symmetry? All right, so here is a formula that you're going to write down right here. So this formula right here is for the axis of symmetry. It's a very easy formula to use. And based on your equation that we had, y equals x squared minus 6x plus 5, okay, that was our equation that we wrote in standard form. Standard form means that you have your squared term first, your x term next, and your constant last. So just like before, we learned that your a term is the x squared term, your b term is the x term, your c is the constant. Same letters we're using. So when you see this b and this a, you know you're looking at these two terms right here, okay, because they go in alphabetical order, a, b, and c. Now, how do you read this negative? So see how the B term is negative, so they put it in parentheses, okay? But you also have a negative in the formula right here. So this negative is that one. And then your B term is -6. There it is right there. Divided by, bring down the 2 that's in the formula. And then the A term, the invisible coefficient, is 1. Okay, so a negative divided by a negative is a positive. So 6 divided by 2, that is how they got this x equals to 3. Okay, that's where that came from. That is called your axis of symmetry. Okay. All right, let's move on. All right, so here, we've already identified this, but they're, just pointing out your vertex, and then they just read the coordinate. All right. So what you're going to notice is that these two numbers are the same, and they would be the same because that line is cutting right through the vertex. So the x coordinate would be the same as the x in the vertex, okay, in your axis of symmetry line. Okay, so that number and this number will always be equal, okay, because it's cutting right through the vertex. All right, so now we're going to talk about the y-intercept. So right here, just put a line right where it's crossing the y-axis. Just put a line that says y-intercept. Okay, I'm sure you guys know y-intercept, just like when we were graphing linear equations, is where the line crosses the y-axis. Okay, now, when it's in standard form, it should be your c term. See how it says +5? That is your y-intercept. When it's in standard form, it says the c would be your y-intercept when it's in standard form. And then, of course, you can look and see what it is. Okay, you can just look on the graph and say, okay, it's crossing right here on the y-axis at 5. All right, now for the x-intercept, and this is how we write the answer. So you'll just put it in the little set brackets. All right. All right, now there are several names we use for x-intercept, just like we did for linear equations. We can use root, so there's a little acronym you can kind of help yourself remember all the different ways to say x-intercepts. So we got roots, zeros, x-intercept, solutions. And the root word to solutions would be solve. Okay, so even if it says solve the quadratic equation, you are looking for x-intercepts. Rocks, that's right. Okay, so just make sure you know all of those words, because I could ask on a test the same question 4 different ways. I could say solve the quadratic equation, I could say find the roots, I could say find the zeros, or I could say what are the x-intercepts. Okay, so vocabulary is very important. So just identify the x-intercepts. That's where the line crosses the x-axis. So in this case, you have 2. Okay, you have an x-intercept on this side, x-intercept on this side. Can you not have an x-intercept at all? Yes. Okay, so we're going to draw some other pictures that you want to add. Okay, I'm just going to draw another picture of a parabola. And this would be a case where you do not have an x-intercept. So if it's not touching the x-axis, because here's your x-axis, if it's not even touching the x-axis, then you simply write no solution. Okay, you need to know that, so please add that somewhere. Okay, if it's not touching the x-axis, then you write no solution. You could also have a situation where you only have one x-intercept. And that's really like when the parabola, the vertex of the parabola is touching at one point. So you would just have one answer, like, 3. Okay. So for parabolas, you could have 2 like this. You can have none, or you can have one solution. Okay, so those are your options: one solution, two solution, or no solution at all. Okay. So if that vertex is sitting right on the parabola, on the x-axis that is, then you're only going to have one answer. And it'll be, visible if you use your graphing calculator. You can tell how many solutions you're looking for. Now this one had two, so see how they wrote the answer? They wrote the answer in set notation with 1,5. Don't use parentheses. So when you're actually listing the x-intercepts, they're not coordinates unless you write it as a coordinate. Okay, your option would then be 1, 0, and 5, 0. So if you write it like that, you can write it as a coordinate. But if you're just listing where it crosses the x-axis, you should only use the set notation. Okay. All right, so the next thing we're going to do is go to... All right, so on page 1 in your packet, you'll see, and this is going to be your classwork and homework as well. You'll definitely see 4 things that you're going to have to do on this page. Okay, and I know some of the graphs didn't come out that, didn't copy that well. So if you want to use your own graph paper, that's totally up to you. All right, I'm going to start with question number 2. So I'll do a couple of these on the page so you'll know what it's asking you to do. Okay. So in number 1, it says you're going to obviously graph the function. You're going to simply put it into your calculator. So this will be a calculator function that you're going to do. So you'll type in y equals and type in 2x squared minus 4x. So you can do that. And then you're going to make a table. So everybody write make table, and I'm going to walk you through the process in a second. And I want to have 5 points. Okay, we'll have a total of 5 points. And then when we do the axis of symmetry, which will be the next thing, we're going to be using that x equals negative b divided by 2a. Now, what I tell students, instead of calling it negative b, just use the opposite sign of b. Because when you multiply by a negative, it just simply changes the number to its opposite sign. So always say x equals the opposite side of b divided by 2a. And then you don't have to be writing down all those negatives. Okay, then we're going to write the vertex. And again, you can get that right from your calculator. I'll show you how to do that. And then we'll look at either our table or our graph and figure out where the line is crossing the x-axis, right? So step 1, let's go ahead and do number 1. So everybody hit your y equals key and put in the 2x squared minus 4x. And then you're going to go to your table, and we're going to make a t-table off to the side. Okay. Now, our standard numbers that we use when we're graphing, we like to use some negative numbers, 0, and some positive numbers. Okay. Now I'm going to just use -2, -1, 0, 1, 2, 3. Okay, obviously I have 6 numbers, but I think one of these are going to be too large to graph, so I just added another number. And you can do that. Just try to pick some numbers that will actually fit onto a coordinate plane. Okay, because you don't want to have to make, numbers like 16 and 20 and so forth. So sometimes you might have to choose different numbers. So then once you go and hit second graph to get to the table, we're just going to go ahead and fill in what y values pair up with the x values. So can someone tell me -2 pairs up with what? 16? So we know we're not going to be graphing that, okay, because that's just too big. -1 pairs up with what? 6. 0 pairs up with 0. How about 1? And 2? And 3. 6. Okay. So now we're going to go ahead and plot the points. So after you hit your y equals, make your table, you're going to plot the points. Okay, we're not going to plot -2, 16. So we're going to start at -1, 6. 0, 0. Okay, 1, negative 2, 2, 0. So I can already tell where my x-intercepts are, because when you're on the x-axis, y is 0. And then 3, 6. Okay, so then you're going to go ahead and connect them all. And it's always a good idea to look at your calculator to make sure your parabola looks like the one you graphed, right? Okay, so that's step 1. We've already taken care of just graphing. Like I said, that part is easy. Step 2 is to now write the equation for the axis of symmetry. Okay, so I'm going to write x equals the opposite sign of b divided by 2a. Okay, that is our axis of symmetry formula. So I'm going to look at this equation up here, and I'm going to look for the b term. Okay, which one is the b term? The x term. So what is the opposite of a negative 4? Positive 4. I'm just going to, I don't need to write a negative and a negative. Okay, I just simply say the opposite sign of b, because when you multiply by a negative, it just changes the sign. Okay, divided by 2 times the a term. What is my a term? 2. So 4 divided by 4 gives me what? 1. So there's your axis of symmetry. X equals 1. And you want to write it as x equals 1, okay? Because it has to be the equation for your axis of symmetry, which means, again, it cuts it right in half right here. This is your x equals to 1. And actually, put a little line that says x equals 1. Okay, right there, cutting it in half. All right, so we've done 1 and 2. The next thing says, write the vertex of the graph. So now, okay, step 3, you want to look in your table where x equals to 1, and I'm going to write it down so you'll know it. You need to write these little notes down, so when you have to do it, you'll say, okay, when she did part 3, she said, look in the table where x equals to 1. Okay, because that's what it says in number 2. So if it says where x equals to 6, then you look for x is 6 and find the y value. All right, so it's already in my table right here where x equals 1, right here. And there's my vertex, 1, negative 2. It's that simple. Okay, you look in the table, okay, where x was 1, and then it pairs up with negative 2. Okay, so that is your vertex. Because remember I told you this number here and this number here are the same. So you can get the y coordinate right in your table. Now, what if it wasn't an integer? What if my axis of symmetry was 0.5, like 1/2? How would I get it from the table then? How do you change your window? You might want to put that note at somewhere. To change the window, write it down. You hit second what? How do you change your window? Well, let's say it's to change the table, because you guys might not know that. To change your table to 0.5, what do? You hit second window. So everybody hit second window so you'll know how to change your table, because your x-intercept, your axis of symmetry may not always come out to be an integer. Okay, it might be a decimal. Okay, so if I had like 1.5 instead of x equals to 1, and it says x equals to 1.5, then you hit your second window. You would just type in 1.5. And then when you go back to your table, 1.5 will be at the top of your table. Okay, so you need to know how to do that in case it comes out to be a fraction or decimal. You can just type in and change your table. All right. Identify the solutions. Solutions are what again? What are solutions? Your x-intercepts. Okay, so we can see that the x-intercept is 0 and what? And 2. So that's what you write down. 0 and 2. Now, you can get that from the table because when you're on the x-axis, the value of y is 0. So those would have to be your x-intercepts. Okay, and that's what you're going to be doing for all of these. Okay, now let me tell you how you can tell before graphing if your parabola is going up or down. See this a term? If this a term is positive, your parabola will be going upward. If the a term is negative, like in number 1, then when you graph it, it's going to be going downward. So that's how you can tell before you graph. Like this one, I already know before I punch this in, this is going to be going down. This one will be going up because the x squared term is positive. Okay, so that's how you can tell little things about the parabola. Like this one should be going down, and this one will be going down. Okay, before you put it in, if that squared term is negative, that means it's going to be going downward. All right, so let's do number 1. All right, we're going to do number 1. We're going to follow the same thing that we just did. All right. Now, in number 1, you notice there's only the a term. Okay, so when you are missing the b term, then that means b is 0. So whatever term you're missing, if you don't have all 3 terms, you will always have the a term because it's not a parabola unless you have the square term. But if you're missing the b term or the c term, then that means those values are 0. Okay, so you need to know that because you might not have a b term all the time. All right, so the first thing we're going to do is sketch the graph. So go ahead and punch this into your calculator. Okay, and then we're going to make a t-table. And you can hit graph just so you can see what it's going to look like. And I would always do that. Okay, even if I know, I would just simply still hit graph so I got a good picture of what mine should look like when I'm done. All right, so somebody give me some numbers here. -2 pairs up with what? -4, -1, 0, 1, and 2. All right, now this one I'm not going to graph, so you go ahead and plot the points. Okay, and then after that, we'll go over, the rest of the 2, 3, and 4. And you have to have this t-table. Okay, so please just, you're going to just continue to model exactly what I've done here is make a t-table for question number 1. All right, now, once you have them all plotted, okay, go ahead and connect them, of course, put arrows at the end, and just double check with your calculator to make sure your graph looks like the graph that's on your calculator. All right. So now we're going to fill in number 2, which asks you to find the axis of symmetry. So I just said that when you don't have the b term, it's going to be 0. Okay, so it's just 0 at the top, divided by, and it really doesn't even matter what you divide by, because if 0 is at the top, your answer is going to end up being 0. But we're going to put 2 times -1. So your axis of symmetry is x equals to 0. Okay, so circle that, box that. That is the answer for the axis of symmetry. All right. Number 3, it asks you to write the vertex. So how do you find the vertex? You go to your calculator, go to your table that you've already identified up here, go where x equals to 0. And write the y value, which is also 0. So your vertex point is 0, 0. Now, I forgot to say in number 3, you do want to tell me if that's a minimum point. In the first example we did in number 2. So make sure you say the vertex over here was a minimum point. All right, you can put min, and this one is a maximum point. Okay, because it's going downward. So it's at the top of the parabola. Okay, when it was going up, it was at the bottom of the parabola. So make sure for number 3, on question number 2, that you put it was a minimum point. All right, and then the last thing it asks for the solutions, which are your x-intercepts. All right, so for the x-intercepts is also going to be 0. Okay, because that vertex is sitting right at the origin. So it's only touching the x-axis one time. So those are the 4 things you're looking for the ones that have graphs. So for questions 3, 4, and I believe 5 and 6, you're doing the exact same thing. Okay, finding those 4 things for each one. All right, any questions?